An enclosed building on open flat terrain is being constructed. Calculate the design wind pressure acting along the walls and roofs. For this problem, we are already given the velocity pressure exposure coefficient and our external velocity exposure coefficients. Pardon me, external pressure coefficient. To solve this problem, first of all, we need to calculate the velocity pressure for the structure. And the velocity pressure can be solved using the formula 0.00256 times the velocity pressure exposure coefficient times the topographic factor times the wind directionality factor velocity squared. And now this equation is long. Let's try to simplify it so that we don't have to worry about all these different components and variables here. First of all, 0.026, we can keep it as it is. And we do know that our velocity pressure exposure coefficient will be different for different heights. So we're going to keep it as it is because it's variable. But we do know that our topographic factor will be 1 because we do know that this building is located on a flat terrain. So that means it's always going to be 1. And similarly, our wind directionality factor will be 1 because we are assuming that only wind is acting on this structure and nothing else. And we know that our velocity for wind is 105 miles per hour squared. And simplifying this, we get 28.22 times our velocity pressure exposure coefficient. And because we already know our velocity pressure coefficient from the values given to us, we can actually calculate our velocity pressure right away. So first of all, we can calculate for 0 to 15 feet on the windward side of the wall. And using the value for our velocity pressure exposure coefficient, which is 0.85, we get the value 24.4. Similarly, for our velocity pressure exposure, we get 25.4. Sorry, I'm not writing the whole equation again because it's just repetitive and you can do it on yourself. And for 25 feet, we're going to get 26.5. And for our height, the whole height, which is this here, it's 31.6 feet, we're going to get 27.9 pounds per square foot. Got to write here, units. Okay, now that we have the velocity pressure, we can move over to the next equation, that is our design pressure equation. And for this equation, we have, first of all, our velocity pressure times the gust effect factor times the external pressure coefficient. And subtracting it out of this, it'll be the velocity pressure for the other sides of the building times the wind gust factor times the external pressure coefficient. But one thing to note here is that we're going to put both of these in brackets and then it becomes our internal pressure coefficient. Internal pressure coefficient. And now let's just try to simplify this problem equation so that it's less cumbersome. So we do know that our velocity pressure velocity will our velocity pressure will be different. So we can't change it, but we do know that our wind gust effect factor will be same for every time, and it'll be 0.85. And we also know that our external pressure coefficients will be different for every different height and different sides of the building. So we're going to keep it as it is. But we do know that our velocity pressure for the other sides of the building will always be same because our height's not going to change. And we already calculated it. It's 27.9 pounds square foot. And our internal pressure coefficient for this particular building will be plus or minus 0.18. Now this value can be found from the ASC publication. Now let's simplify this. That looks nice. And it's 5.03. And now the fun part. Let's solve the pressures, design pressures. First, let's go with the windward wall. The pressure for windward wall. We do know that the pressures will be different at different heights, and we can we can use our given table here to get the an estimate of where to segregate different heights. And based on this, will our first chunk, our first grouping will be 0 to 15. Plug the values in. So 0.85, our pressure velocity, we already know that it'll be 24 pounds per square foot times our external pressure coefficient, which is given as well, and it's 0.8 plus or minus 5.03. Solving this, we get 11.3 pounds per square foot or 21.3 pounds per square foot. Similarly, now we can go over to the 20 feet mark and using the same formula, 0.85 times zero point 0.9 pounds, sorry, zero point 0.9, that's our external pressure coefficient, times 20, which was it, 25.4 pounds per square foot, plus or minus 5.03. And solving these two values, we get 12.2 pounds per square foot, or 22.3 pounds per square foot. Similarly, we can solve for 25 feet, but I've already done it for you, so it's 13.0 pounds per square foot, or 23.1 pounds per square foot. And now for the leeward wall, our pressure will be 0.85 times the velocity pressure exposure coefficient. Oh, my bad. Sorry. So now will be the velocity pressure that was 27.9 pounds per square foot, and times our external pressure coefficient, which is negative 12.5 plus or minus 5.03. Solving this equation, we get negative 16.9 pounds per square foot, or 6.84 pounds per square foot. Now our side wall, it's similar to what we did for leeward wall. So it'll be 0.85 times our velocity pressure, 27.9 pounds per square foot, times our external pressure coefficient, which is negative 0.7 plus or minus 5.03, which is equal to negative 21.6 pounds per square foot, or negative 11.6 pounds per square foot. Now moving over to the roof. So our windward roof would be 0.85 times 27.9 pounds per square foot times the external pressure coefficient, which is negative 7. So this means it'll be similar to our side wall. And the values were 21.6 pounds per square foot, or negative 11.6 pounds per square foot. Finally, our leeward roof, it will be 0.85 times 27.9 pounds per square foot times our external pressure coefficient, which is negative 0.3 plus or minus 5.03 equals 2. And this comes up to negative 12.2 pounds per square foot, or negative 2.09 pounds per square foot. And there we have it, our final answer for design pressure for this enclosed building.